What we are discussing today is how ChatGPT deals with foreign languages. And I'll explain in a second what kind of foreign language we're talking about. Specifically, if we ask the question, how many languages does ChatGPT actually speak? Now, we do know that it speaks well in terms of computer languages like Python or C++. How about other European languages other than English? How about some other language which are major languages but not necessarily in the top three, such as Hindi, which is probably the fourth largest spoken language in the world, and Bengali, which is probably the sixth largest spoken language in the world. I'm leaving out other things like Mandarin or Japanese, of which I have very little knowledge. So I'm just going to pull out the curtain just a little bit so that you can see what exactly is ChatGPT doing and how. Let me go back to the question of ChatGPT's capabilities in terms of structured computer languages. So, for example, I asked it to run a multivariate regression with diagnostics in Python. And it immediately gave me the Python codes. I have listed some of them. It goes on and on and on. And then it gives you what it does. It explains all the comment lines and so on. And so the question naturally arises, with just that amount of information, can we actually run the program with a data set which does the job? The answer is yes. I checked it out and it does. So there's no question about that. Why is this important? It's important for a number of reasons. First, ChatGPT was supposed to be about natural language. And if you think about natural language versus computer language, they're not the same thing. Computer language have to have a very rigid structure. Otherwise, it doesn't work. If you put a comma at the wrong place or a colon at the wrong place, it's not going to run. So it has a very, very rigid syntax, whereas natural languages are much, much more flexible and much more nuanced. So, for example, I eat rice. That statement versus rice I eat are not quite the same thing, as any English speaker will tell you. Similarly, for every other language, even though it has the same set of words, don't necessarily mean the same thing. Now, let me back up a bit and say just a few words about the GPT itself. So GPT stands for Generative Pre-trained Transformer. Each of those things have very, very specific meanings. So generative means something very specific. Pre-trained, the term is fairly obvious. Transformer is a type of language used in the artificial neural network terminologies. So it's a basic transformer neural network architecture. That's the whole basis of it. So at the end you have some inputs, which we call encoders, converts that into a sequence of tokens. Essentially, it does a transformation, either a logistic kind of transformation or TAN-H transformation, and then that gets converted into another set of numbers. So what you have to do during all of this is make sure that none of these things, when you go from one step to the next, that things don't explode. So you renormalize it and so on. So what are these tokens? Tokens are, in this case, words or characters. It could mean parts of the words too, depends on the context. So with all the transformation, then it goes to a decoder, and then decoder produces the output, which is what you really want at the end. You don't want numbers, you want some words. So in all of this thing, what took a quantum jump in this process is a paper that came out in 2016-17. It's called Attention is All You Need. So this paper, I have just produced the top half of the first page. You will see it has intimate connection with people in Google. They are the ones who started this whole business. Not all of it, but most of it. And so you would naturally expect Google to be actually using this kind of stuff, and they do. For all their translation business, it is all about these GPTs, even though it never says it so out loud, but it is. Now, so what this particular paper did was the original transformation that they were using in order to go from the input token to the output tokens, they were getting convoluted network and that sort of recurrent networks. Those things gave rise to models that are very, very complex, and this attention business, which has a very specific meaning, I'll talk about that in another lecture, that cut through all of it and made it very, very simple. So what took hours and days to translate just became a matter of milliseconds. And that's a huge, huge jump. So it simplified input to output with this, what is known as the attention function. And it cuts down on the transition matrix. I'll explain in a second what I mean by that in the context of language translation. And that simplification meant a huge, huge jump. So if you think about a matrix, what we think about a matrix in terms of all the elements in a matrix, where the diagonal elements, if they're all one, then it does nothing. It just reproduces what it was in the previous one. It's the off-diagonal elements that interest us. In this case, this is taken from a paper that looks at how generative languages go from English to French. So this is an English sentence at the top and the corresponding French translation. What it has to do in order to do the translation possible is to do this analysis to find out what off-diagonal elements are important. Remember, diagonal elements are not that important in that if you have only diagonal elements, it just spits out the same thing as input. So it's the off-diagonal elements that we are looking at. If you have lots of off-diagonal elements, that makes the translation difficult, more time-consuming, and that is what this transformation that I'm talking about does. It basically cuts down on the off-diagonal elements so that basically you can invert the matrix very, very quickly. So what it eventually does, it produces a probability distribution over the vocabulary that you have at the end. In other words, it really, really does not know that the English word actually has a French word with 100% certainty, but it gives you with a very high probability on the French word, so you know it's not that off. So how does this process end? This process ends until a stopping criterion is reached, and then it spits it out. What kind of stopping criterion do these kinds of generative models use? So usually they are used for the maximum length of the sentence or whatever translation you're doing, or end of the sentence token, like a period at the end. And then it spits it out. Remember, it takes only a very, very tiny fraction of a second. So ChatGPT actually trained, if you like, in these kinds of languages with lots of different languages. So what I was interested in is to see, does it have enough pre-trained data on languages that are not usually out there with that many web pages on the web? And that is important because recall that most of the training of ChatGPT came from training through web pages in one form or another. Now, what I wanted to test it on is on a Bengali dish. So this particular Bengali dish is very, very common in both Bangladesh and West Bengal, but not in the rest of India. So this main ingredient of this dish is a kind of a spinach. The top name there is the scientific name. It is not, I don't want to suggest that it's not used in other cuisines. It's used extensively in lots of Asian countries as well as in African countries. But this particular dish I'm talking about, that I'm about to tell ChatGPT to tell me the recipe of, is very, very specific for people who speak Bengali. And it's, as I mentioned, it's cooked mainly in West Bengal and in Bangladesh. So let me just back up a bit and say a little bit more about the Bengali language. So Bengali language is largely spoken in what used to be called Bengal. Now it's divided into two parts. The East Bengal became Bangladesh, most of it, and West Bengal, the western part of Bengal became West Bengal, part of India. The other is a separate country altogether. And it is spoken by about 300 million people. So it is actually spoken by more people than who probably speak French. There's some dispute about whether that is so or not, because a lot of these people who speak Bengali are not necessarily native Bengali speakers, but they are fluent enough in Bengali nevertheless. Now, the important part to understand here is that this Bengali speakers are concentrated in a very, very specific geographical area that is indicated in this map. The dark green is where most of these people are. There are some here and there, as you can see in the map of India, that there are some pockets of Bengali speakers. Not very large numbers, but nevertheless in hundreds of thousands for sure, in other parts of India as well. And then you have some pockets of Indians and Bangladeshis who migrated to other countries. So here we get into the nitty-gritty of things. I have to do that in Bengali, but I'll also do some translation so that you know what I'm talking about. So what I asked it to do is to cook me this particular spinach in a very, very Bengali way. In Bengali, I would say, what I said was, আমাকে পুঁই শাকের চচ্চড়ি বানাতে শেখাও. Teach me how to cook this চচ্চড়ি of পুঁই শাক, which is the spinach that we're talking about. So when I did that, it paused. Unlike if you put something in English or Spanish or French, it immediately starts to tell you something. So here GPT took fairly long time, about 45 seconds before it started to say anything at all. And then it said, আমি শেখাতে পারি, meaning yes, I can teach you. And then it goes on to what I've listed here, upokaron, which means ingredients, or what the ingredients are. Okay, I don't bore you with the ingredient detail, but what I want to point out is what I have highlighted here in red, because that's relevant. It says one ingredient is zero. There is no such thing as zero in Bengali as an ingredient. What is there is jire. So jire and zero are not the same thing. However, in Bengali, we often mispronounce zero as jiro. So what ChatGPT is not very sure of is the distinction between the two. It puts in this context, it should have been jire, but as it doesn't know quite well what it is, it puts zero. This is what I have highlighted in red. Now, what does that mean? That means the database on words in Bengali in GPT is on rather shaky ground. Same thing happens when I do a similar sort of thing in Hindi, but I'm not going to talk about that here. And then it goes on to say, একটি পাত্রে তেল তৈরি করুন, মশলা গুঁড়ো, গুড়িচ পাউডার, গোলমরিচ পাউডার, লেবু ভেজে মেশান, etc. And then this is the last page I'm going to show you in Bengali. Again, I have highlighted two separate words. One is at the top line, which says in red, bhaje. It should not say bhaje, it should say bheje. They're not the same thing. So again, it highlights what the Bengali word it actually misses. It's not quite right. And again, that points out to the sparse matrix that it has for its Bengali vocabulary in the first place that it's trying to translate. And in the last line, it says a word, shaduto, which is not Bengali, quite a Bengali word. It should have said shadushto or something to that effect. Or shadu would have been okay, but it does not. So it errs on these things. Again, all of this points out to the sparseness of its Bengali database. Now, the part that I want to say a couple of things about is what I did with that was then actually happened accidentally. I was trying to transfer those words into my Gmail, and when I did that, Google immediately picked up on some of the errors in spelling, which means that the technology behind Google's Gmail is more sophisticated than that of the ChatGPT. However, it did not pick up all the errors that were there. So Google still has some ways to go to accomplish that. But it is clearly more advanced in that sense than the corresponding ChatGPT is. So the point here is I want to test out how GPT is dealing with foreign languages, especially non-European languages. So what I've done here is to give you an example on what happens when it tries its hand in Bengali. Thank you.